Good afternoon, everybody. My name is Moutushi Dey, and I'll be talking about the importance of using selective catalytic reduction filtration systems in transition from fossil fuel to renewables. Here is the outline of today's talk. I'll introduce myself and talk about my motivation. Then I'll briefly explain about the fundamentals of SCR-based filtration systems. Then I'll discuss how to create new markets or new demands for SCR-based filtration systems, in strategy language, how to create a blue ocean. We know that we are in the age of AI, so next I will discuss how to use AI in CO2 emission reduction, and then at the end I will talk about the partnership models that are needed to create new market demand for SCR-based filtration systems in sectors other than transportation and to help achieving sustainable development goals. Here is all about me. I have a PhD degree in chemistry from Guwahati University, India. I completed some certifications from Harvard Business School online, and I am currently enrolled in the Wharton CTO Executive Program. My main areas of expertise include sustainable product and process development, manufacturing, product commercialization, and strategy development. In the past, I worked at Center for Composite Materials, University of Delaware, Honeywell, Air Liquide, and Donaldson. While working at Donaldson Company Incorporated, I came across this selective catalytic reduction based filtration system, and I felt, and these are all great engineered systems. So here is about my motivation. So this year, January 26th was celebrated as the first International Day of Clean Energy by the United Nations. The United Nations is trying to boost rapid transition to sustainable energy, and that is a top priority for them. UN wants to reduce global emission by 45% by 2030 and then reach net zero by 2050. And by global emission, we mean here every types of emission, so CO2, NOx, particulates, or any other form. Now, the United Nations has 17 sustainable development goals, and if you look at number 9, it talks about the building resilient infrastructure and also building sustainable innovation and sustainable industrialization. So, looking at all these great work, I felt really motivated and I felt curious to understand how to make our planet carbon neutral and rapidly while going from fossil fuel to net zero, and how to use some easy to adopt solutions. I also felt curious to understand if enhanced partnership between governments, academia, and industries can help this human race to survive climate disaster. Now, let's look at the fundamentals of these SCR-based filtration systems. I am showing on the left-hand side of the slide, I am showing one schematic of SCR system. These systems are generally used in transportation. And there are 3 general methods to control emission in transportation as well as other sectors like shipping industry where fuel is the diesel. So, you can basically take one after treatment system and use it, or you can use sustainable fuel, or you can change your engine combustion parameter. Now, SCRs are actually these sustainable engineering system, and they are actually the after treatment system which can reduce NOx emissions significantly by around 90%. So, looking at all these schematic, I was thinking that can we use it for any other application. Now, to explain them very briefly how they work, there is a exhaust inlet and there is another inlet for injecting urea water solution. When urea water solution is injected and the exhaust gas being very hot, water from the urea water system gets evaporated, and then 2 events occur, thermolysis followed by hydrolysis, and that results in the formation of amine. The amine can then react with the NOx emission in the exhaust stream and then form nitrogen, and that happens in the catalyst bed. So, engineers, they always try to improve these SCR based systems, and they can do it by doing different types of parametric study. They can change the system design, or they can change the catalyst bed to make it more effective to enhance the capability of NOx reduction. Now looking at this, I was thinking that is it possible to change the catalyst bed a little bit, or is it possible to change the system design a little bit, or look at other parameters and use it in other industries like manufacturing industry or coal plant or any other industry where CO2, NOx or other particulates are being generated. So that was a thought process, and I started looking for other case studies or other research where people have tried to look at other different application outside of transportation. And I found one. So I showed the one of the references here. This is a pretty new reference. This research came out in April 2024. And a brilliant group of researchers, they actually thought about this long before I thought about it, and they tried to apply this in these SCR based systems in NOx reduction in shipping industry. Now I would like to mention that shipping industry is also another very important industry where we should focus on, because around 90% of world's foreign trade volume is being transported by sea. And these ships are huge and they consume lot of fuel, and that fuel is diesel, so that is producing lot of emission. So this group of researchers, they actually tried to improve the design, and they tried to change the design and make it usable for shipping industry. But they mentioned that there are other workers who have tried to change the catalyst. They tried to change the catalyst type. They suggested using different types of catalyst or single atom as catalyst, and they tried to use it to enhance the efficiency of these NOx systems. So now the question comes, if we want to use this for any other application in our region or in our city, how do we do that rapidly? So I am suggesting this workflow for application of SCR based system in some other application. So for this, initially we will have to have some sort of assessment of other industries, and then we will do parametric study. Parametric study can be done on the system itself or on the system design or on the catalyst, and then we will choose some easy design change or easy catalyst change as per application demand, and then take those for further evaluation and validation. So this looks like a lot of work. So how do we do that? So I am going to talk about that in my partnership models. Next, I tried to look at another pollutant, that is CO2. Now we know that, and I tried to understand how other people are measuring CO2 emission in different parts of the world. Now we know that CO2 emission can come from a variety of sources. It can come from industrial sector, it can come from combustion or construction sector, or transportation sector, or urban household sector. So it can come from a variety of sectors. Now researchers have worked on different industries. They consider different industries and try to see the energy consumption in different industries. And one group of researchers, they found that in some parts of the world, especially in developing countries, the industrial sector is the main contributor to CO2 emission. And they also mentioned that coal consumption was behind the main contribution to CO2 emission. Many researchers, they pointed out that industrial structure upgradation actually helps in reducing CO2 emission. So industrial structure is very important, and that makes sense because if you have a better industrial structure, there is no leak and you are using less energy. So based on all these case studies search, I came to this conclusion that AI can really reduce the CO2 emission and help us in that in both direct ways and indirect ways. In direct ways, you can better basically control and detect or optimize. They can also help us in carbon capture and storage. In indirect way, actually it can reduce energy emission by upgrading industrial structure. So whenever you are trying to implement AI in manufacturing or in any industrial processes, then you are trying to upgrade the structure. And whenever, or if you want to connect AI to IoT, you will have to upgrade the structure. So upgrading the structure is very important. Indirectly, it can also help us by disseminating knowledge. So now people know more, so they will be more aware about the facts. a group of researchers, they found that AI had no positive impact on carbon reduction in cities with poor infrastructure, but AI was able to reduce carbon emission in cities with better infrastructure. So about AI, I would like to say that we are still trying to understand different aspects of AI implementation in manufacturing or in other industrial processes, and there is a learning curve. So I was thinking that in those situations where implementation of AI would require a long time or a big effort to get usable AI models and test them and validate them, it might require a long time. And in those situations, can we use selective catalytic reduction based filtration systems instead? Can we use the concept of blue ocean strategy and try to change something in the catalyst side or something in the design change side, or change then use it in other applications? So for implementation strategy, there are many different implementation strategies available, and one of them is OODA. So that is observe, orient, decide and act. And I'm suggesting OODA because in any region or any sector, if you want to apply these SCR based filtration systems for other applications, you need to understand which sector is causing your pollution. So in any region, there might be several sectors: industrial sector or combustion sector or transportation sector or urban household sector that are causing pollution. First, we need to understand and see the emission data from all these sectors, and then understand which sector or sectors are causing the greatest, highest pollution. When we observe that, then we can orient our focus towards that sector or sectors, and then we can decide what type of change we want to make in the system. Is it in the system design or the catalyst, and then act accordingly. So for any strategy implementation, it requires partnership. Partnership is so important, and it's very important, especially when you are trying to solve a problem like climate change, which is a global issue. So there are many theories, many models available. One of them is intermediary organizations. Now, intermediary organizations are known as facilitators of innovation, or knowledge brokers, or innovation brokers. Clarks and Lewis, they were the first who coined the term facilitators of innovation. So they are basically intermediary between 2 or 3 different organizations, and they are mediating between 2 and 3 different parties, and they act independently, and they produce distinctive value beyond what each of these constituent parties can provide. Another important thing is they always want bridging the gap between science and policy, and that is so important, and they try to share knowledge through collaboration. So I have shown one example of intermediary organizations here. So this is one mediator between United Nations and local government and business or technology ecosystem, but we can be quite creative in designing these partnership models. They generally work by co-governance model, so you can develop a mixed resource strategy, and you can develop to some sort of network structure between all these levels. These are known as micro, macro and meso levels. So intermediary organizations are also known as meso levels because they're in between micro, that is one individual academic institution or industry, and macro level, that is institution like United Nations or local government or the government. Idea exchange is very important, and that always happens through the IOs, and you can also develop advocacy groups to suggest inputs in regulation. So based on all these studies and case study research, here are my conclusion that the SCR based filtration systems can be well known, easy to adopt solution for infrastructure improvement with minimal effort. AI has proven capability in improving carbon emission in direct or indirect ways. The industries where AI implementation might require a very big effort, modified SCR system might have the potential for industrial structure upgradation and hence less energy consumption and emission reduction. Partnership development, leadership involvement, and knowledge sharing. These are the only ways to achieve net zero. Lastly, I wanted to share my daughter's picture. This is my daughter when she was just 6 years old. This was her first ballet recital. As a mother, I want to see her smiling for years to come. My daughter and all our next generations, they inspire me to think about sustainability in every possible way, learn through collaboration, and solve problems through knowledge sharing. Thank you for listening.